Okay, so let's talk about translation and codons. So we just made some messenger RNA through the process of transcription, and now it's time for translation, which is basically translating the nitrogen-based code into amino acids, which is the primary structure of a protein. So in eukaryotes, transcription happens first in the nucleus, followed by translation in the cytoplasm, where the RNA processing has already happened in the nucleus to make mature mRNA to leave through a nuclear pore to enter into the cytoplasm. In prokaryotes, transcription and translation are happening together in the cytoplasm at the same time. All right, there's no RNA editing there. So now let's go ahead and look at this mature mRNA. I can see the 5' cap and the poly A tail. So we have a ribosome comes in two parts. You have a small ribosomal subunit and a large ribosomal subunit that will come and attach to the mRNA. Now, when the ribosome reads the messenger RNA, it's going to read it in things called codons in groups of 3. And so this is sometimes referred to as the triplet code. So here is our first codon. This is called our start codon, AUG, and it's always AUG. That's always first, and that will code for the amino acid methionine. Now, the next codon, which is a group of 3 bases, is ACA. So that codon is going to code for one amino acid, and that amino acid here is threonine. So when we talk about the ribosome reading the messenger RNA, as it moves down, it's going to read it in groups of 3 called codons. A codon is 3 nitrogen bases or 3 nucleotides, and it's going to code for one amino acid. Now, it's not a random amino acid. There's something actually called the genetic code, and this is the genetic code table to help us figure out which codon, which amino acid that codon is coding for. So our start amino acid was AUG. So the first letter is an A. So I'm going to look here on the left. And then my second, so that means my amino acid that I'm looking for is somewhere in this row. Now my second letter is a U. And so now that means wherever the A and the U cross paths, my amino acid is somewhere in that box. And then my third letter was a G. AUG was my codon. So now I find that, oh, here it is. So my amino acid that AUG codes for is MET, or methionine. So here we can see our first start codon, AUG, so methionine. Then our next codon is GUC. If you use that genetic code, that would code for valine. And then it would continue down codon by codon by codon, each one coding for a different amino acid. All right. Oh, I should mention though that there are 64 codons and only 20 amino acids. So if we go back to this table, you can see how an amino acid like leucine, for example, or let's go with proline, it's right there, easy to see. When we talk about proline, let me write on it for you. So you can see how this codon, CCU, codes for proline, but so does CCC and CCA and CCG. So the genetic code is somewhat redundant, which is actually nice because if a mutation happens in that third spot, it doesn't change the amino acid, which is called a silent mutation. All right, great job.